Hello and welcome back to the Geology Dean's Masterclass on sedimentary rocks. In this episode, we're diving into the fascinating world of sedimentary structures. Think of these as the storytellers of the rock world, preserving tales of ancient environments right before our very eyes. When you look at a sedimentary rock, you're not just seeing stone, you're seeing a snapshot of history. So, what are these structures? They are the physical features within sedimentary rocks that form during or shortly after deposition. The most basic one is bedding, or stratification. These are the layers you see in cliffs and road cuts, each layer representing a distinct period of sediment accumulation. A change in layer could mean a change in sediment source, or perhaps a shift in the energy of the environment, like a calm lake becoming a fast-flowing river. Now, let's get a bit more detailed with cross-bedding. Imagine ancient sand dunes, either in a desert or underwater. As wind or water pushes sand grains up one side of the dune, they tumble down the other side, creating angled layers. These inclined layers, preserved in rock, are called crossbeds. By measuring the direction these layers dip, we can actually figure out which way the wind or water was flowing millions of years ago. It's like having a built-in compass pointing to the past. Next up, we have ripple marks. You've probably seen these on a sandy beach or in a shallow stream bed. They're small, wavy ridges formed by moving water or wind. When these get preserved in rock, they tell us about the flow conditions. Symmetrical ripples, which are sharp-crested and even on both sides, suggest an oscillating, back and forth flow, like waves on a shoreline. Asymmetrical ripples, with a gentle slope on one side and a steep slope on the other, indicate a current that flowed in just one direction, like in a river. Finally, let's talk about mud cracks. Picture a muddy puddle drying up in the sun. As the water evaporates, the mud shrinks and cracks into polygonal shapes. If more sediment quickly buries these cracks, they can be preserved. When we find fossilized mud cracks in a rock layer, it's a clear sign that the area was once wet and then exposed to the air to dry out, like an ancient floodplain or a tidal flat. These structures are incredibly powerful tools for geologists. Not only do they reveal ancient environments, but they also help us understand deformed rocks. In areas where tectonic forces have folded and faulted rock layers, it can be tricky to know which way was originally up. But structures like ripple marks, mud cracks, and graded bedding, where sediment size decreases from bottom to top, act as geopodal indicators. They provide a clear, unambiguous sign of the original orientation, helping us unravel complex geological histories. So, the next time you see